In this lesson, we're going to review factoring. There are several strategies of factoring that you should have in mind. The first strategy that we always need to check for is finding greatest common factor and factoring it out. So for example, we have a first expression. It's a polynomial with 3 terms. In order to find the greatest common factor, we look at numerical values, numerical coefficients first. You can notice that the greatest common factor here is 4. We also notice a minus in front of the polynomial. It's a good idea to take this minus out as part of your greatest common factor because we would like to leave the remaining polynomial starting with a positive term. When we look at common letters in all 3 terms, we notice that x repeats itself and we're taking x to the lowest exponent. So lowest exponent of x is 1. It's in the 3rd term. So we can take only one x. When we look at y's, also the lowest exponent of y is 1. So one y can be taken out. To find out what's left in a bracket, it's enough to divide each term by negative 4xy. So the first term, if you divide by negative 4, you end up with 3. You divide by x, you end up with x cubed. You divide by y, and y disappear. The second term, because we took minus out, we need to remember to leave the opposite sign. That means minus. 16 by 4 is 4. X cubed by x is x squared. And from y, we have 1y. The following term, minus is taken out, so inside the bracket you have plus. 8 divided by 4, it's 2. X is gone, and 1y is gone, so you end up with 2y's. And this is your factored form. In the following example, we have just 2 terms, this one and that one. And there's no common factor as a matter of numbers, nor letters, but there is a common factor, which is this bracket. So here we have a common bracket. We can take this common bracket out of the 2 terms. Could be written in front, or it could be written as a second. What remains is 2x from the first term and 3y from the second term. So we write 2x plus 3y. And here we have a factored form because we have a product of 2 lower degree polynomials. Let's look at the following expression. Again, we have 2 terms, this one and that one. And the common thing that repeats is the bracket 3x plus 2. So let's underline 3x plus 2 as a common factor. Take it out, 3x plus 2. And again, what remains, I'm going to write in a big bracket because those are larger terms. In the first term, I have x plus 5. Out of the second term, I have 2x minus 1. But there is a minus in front of this bracket, so I need to keep the small bracket inside and open it in the next step. Don't do too many things at one step because it's very easy to make a mistake. So let's open the other bracket and collect like terms. We copy the 3x plus 2 as well. Finally, we can collect like terms in the second bracket. So let's copy again 3x plus 2. X minus 2x is negative x, and 5 plus 1 is 6. So maybe it's nicer to write 6 minus x, not to start with a negative. We have quite interesting example here. We have 3 terms. We do have common factor in numerical coefficients, which is 2. So let's take 2 outside. But we also have the same bracket, except that the exponents are negative. Well, we follow exactly the same rule as before. We take the common bracket to the lowest exponent. So what's lowest out of negative 3, negative 5, and negative 4? Negative 5 is the lowest, so I'm going to take x plus 5 to the negative 5 outside. And what's left inside the remaining bracket? I don't have the 2. I had x plus 5 to the negative 3, and I took it to the negative 5. So I should have the bracket x plus 5 to something. What is this something? Well, you can easily check by multiplying back. When you multiply powers, the exponents add. So we are going to add negative 5 and something to obtain negative 3. Well, the something must be 2, because 2 minus 5 is negative 3. For the next term, you end up with 6 divided by 2, which is 3. The whole bracket is taken out, so there's nothing else out of the second term. The third term, we took the 2, so you still have negative 2. And again, we need to figure out what exponent of this bracket will have to remain. So let's think about it. We have negative 5 plus something end up to be negative 4. So what is the something? Well, the something is just 1. So we don't need to write anything after all, because 1 plus negative 5 is negative 4. You always check by multiplying if you're okay with those exponents. As a last step, we need to look at possible simplification of this big bracket here. So let's rewrite the first factors, 2 and x plus 5 to the negative 5. What's in a big bracket is perform the perfect square, x squared plus double the product, which is 10x, plus 5 squared, which is 25, minus 3, minus 2x, and minus 10. One more step to collect like terms in the big bracket. So copy the first part. And this big bracket may be rewritten as a round bracket already. And we have x squared. Now it's 10x minus 2x is 8x. And 25 minus 3 and minus 10 is 12. At that moment, we can actually check if by any chance we can't factor any further. It happens that yes, we are able to factor this bracket into two linear factors. We are looking for two numbers that multiply to 12 and add to 8, so it's 6 and 2. And this would work. Final answer, this will be 2x plus 5 to the negative 5, and here we have two more brackets, x plus 6 and x plus 2. Obviously, the order of listing your factors doesn't matter as long as all the factors are like that. The next factoring strategy will be factoring by grouping. This time, we don't see a common factor in all four terms. However, we can notice that there is a common factor for the first two terms, and this common factor is actually 2y. So we can factor the first two terms, 2y times 3x minus 2. We can also factor the last two terms by taking 5 as a common factor. What remains is 3x minus 2. Because these two groups are connected with plus, it is very important that we write this plus at the middle. So don't forget to put the plus here, otherwise it looks like it's multiplication all the way. You may be confused that this is already factored form, but it is not, because we have addition here. It's still not a product, but it's closer to the final factoring, because now we can take this common bracket as a common factor out of everything, and what's left is your 2y from the first term plus 5 from the second term, and yes, now we have a factored form, two factors of lower degree. We can do similar grouping in the second example. We can group the first two terms and the last two terms. In the first two terms, you can notice that the common factor is x squared y. What's left is 5 minus x. In the second group, it's a good idea to take not just 2 but negative 2, because we want to end up with the same bracket, otherwise you won't be able to factor. So let's take negative 2 as a common factor, and in the bracket you end up with 5 minus x. It is negative because we took one negative out. Notice that inside the bracket you have a negative because we took the -2 out of the bracket. So finally we can take the bracket 5 minus x out of the two terms, and what's left is x squared y minus 2. The next strategy is factoring trinomials with leading coefficient 1 by guessing method. Let's recall the facts. How do we multiply linear binomials like this, x plus certain number p and x plus certain number q, in order to obtain quadratic trinomial with coefficients 1, b, and c. Obviously, when you multiply, your c term must come from the product of the two numbers, and your b term must come from the sum of the two numbers that you use. So that's the rule to keep in mind. Also, the signs gives you some information. For example, if this sign is positive, you know that both numbers p and q are of the same sign, either both positive or both negative. If this sign would be negative, then the two numbers p and q will be of different signs. That helps to find out the p and q. Well, let's see how can we factor the first example. Again, you always check for greatest common factor first. So in this case, greatest common factor is just 3. What's inside? You have x squared y squared plus 5xy minus 24. Further, well, we need to check if this trinomial is by any chance factorable. Notice that the fact that you have two variables, x and y, it doesn't change much of our problem, because this can be treated as a single variable, which is called xy. And here we have exactly the same single variable xy, but raised to the square. So we can treat this trinomial the same way as just regular x squared plus 5x minus 24. In order to factor this trinomial, let's prepare the two brackets. You know that you have to use the variable xy at the beginning, and then you follow the same rule as in a regular trinomial. The product is 24, and because product is negative, we need to use two different signs, and the sum is 5. This sum actually represents a difference because the product was negative. So I'm looking for two numbers that multiply to 24 and they differ by 5. Well, 8 and 3 would work. 3 times 8 is 24. And we are taking the larger number positive because you need to end up with more positive at the end. We are taking 8 with a positive sign and 3 with the negative sign, because when you add them up, you need to end up with positive 5. So you need to have more on the positive side. 8 as a larger number takes the middle sign. Larger number takes the middle sign. In the following example, we have x to the 4, and on the other end you have y to the 6. So this is a square of y cubed, and that one is a square of x squared. Notice that the middle term comes from multiplying whatever is under those squares. That means x squared times y cubed. So yes, we can still treat this expression as just regular trinomial and think about coefficients the same way as before. How would we factor it? Well, let's prepare two brackets. Copy the first variable under the square, which is x squared, as a first term in your brackets. Copy the last variable under the square as your last term. And figure out coefficients by x cubed. So the product of them will be 42, and they will add up to 13. Well, those two numbers would be 7 and 6. Because 7 times 6 is 42, they add up to 13, we need to use two the same signs. What kind of signs? Two positive signs. So that will be your final factored form. The last example, it looks like it's quite a long one. However, it's actually not so difficult if you notice the common factor first as x minus 3. We can put a bracket here so we have another term with x minus 3. So let's take this x minus 3 as a common factor and see what's left. Well, we have x to the 6 minus 2x cubed and plus invisible 1 here to keep the track after the last term. Now, this is not the end, because you can observe that whatever we have in this long bracket is actually a perfect square. This can be folded back to the perfect square of x cubed minus 1, because you have a square of x cubed, which is x to the 6, double the product, which is 2x cubed, and square of the 1, which is 1. Therefore, the final answer for this question would be x minus 3 and x cubed minus 1 squared. Well, it happens that this x cubed minus 1 can be treated as difference of cubes. And using cubic formula that we're going to cover in this lecture later on, we could factor this even further. So for now, let's leave it as it is, and when we cover the difference of cubes formula, we'll come back to this example. So let's put a star here. We're going to come back to it and factor even further. To factor trinomial with leading coefficient more than 1, we will need to look at a little bit more possible ways of distributing your numbers, because it's not only p and q that we need to come up with, but also some coefficients before x. I will call them m and n. So the product of m and n will give you the leading coefficient. The product of p and q, as usual, gives you the last free term, c. However, the fight is to make sure that we obtain the middle coefficient in the correct way by multiplying the inside terms and outside terms and add them up. How come? Because the middle coefficient involves only x to the first degree, so only multiplying p times nx or mx times q, you obtain terms with single x. Let's see how this will work with the first example. Let's prepare two brackets. Since the last term is 1, that's easy to distribute. We have only one choice for the last number. So this time we are pretty lucky because this number is simple. We have only one possibility. The fact that I have minus, it means that one sign will be minus, the other plus. The leading term in both brackets will be something with x and something with x. The product of these somethings should give me 10. Okay, so I may have two possibilities, either 2 and 5 or 5 and 2. So it's not too many possibilities to check. Well, we'll always check the middle term. If it's, for example, the first case, 2 and 5, then the middle term would be 5x here and negative 2x there. So 5x minus 2x is 3, but it's positive 3. Oh, that means I need to switch my numbers. Well, therefore, let's check the possibility of having 5 and 2 in that order. So 5 here and 2 there should work. Let's check it. Inside product is 2x, outside product gives me negative 5x. When I add it up, I have negative 3x. So yes, that's good. Now I can erase my extra work here. And I have nice and clean factored form. Obviously, difficulty of finding out those four numbers, those four coefficients, depends on how complex are the outside coefficients in your expression. Let's check the second example. Again, let's prepare two brackets. I see 2 as a leading coefficient, so I need to distribute it as 2 and so 1, 2xy and 1xy. So that wasn't too difficult, it's only one possible way. At the end I have negative 9, so the product is negative. I need to use two different signs. It could be plus here, minus there, or the other way around, minus here, plus there. So keep that in mind, that your signs can be changed. And 9 can be split into 1 times 9, 9 times 1, or 3 times 3. Let's see which one will work. You keep in mind that we are fighting for obtaining the middle term to be 3, which means this product and that product of inside numbers and outside numbers, it needs to differ by 3. So how to distribute 9 over here in order to make this product and that product that differs by 3? Well, if I multiply 2 times 3, I get 6xy. And then if I have 3 here, I need to have 3 over there to make it 9. And then the inside product is 3xy. So these two products really differ by 3, which is good. However, my middle term must be with plus. So I need plus 6xy and minus 3xy, which means that this product is positive, so I put a plus here. And that product must be negative, so I put a minus there. Now you can check again by yourself that everything works. And again we can erase the supplementary work here. In both of the previous examples, the outside terms, here it was 1 and here it was 2, those terms are either prime numbers or even 1, which doesn't give us too many possibilities. So that was worth to try and err, because in a reasonably short time we could get those numbers. The next example have both outside numbers composite, so guessing those 4 numbers may not be so easy. We could still do it, but it may take a while. There is another method that we call decomposition. Because we are looking for 2 numbers that we can split the middle term into in such a way that when dropping the outside terms, we can actually factor by grouping. So that's the goal. How this method works? Well, on the side you write down the outside product of the outside terms. So it's 6 times 20, which is 120. You write down the middle sum, which is negative 23. And you're looking for 2 numbers that will multiply to 120 and add up to negative 23. Since the product is positive and the sum negative, both numbers need to be negative, and they need to add up to 23. So let's check some products. You can do it systematically just by listing all possible products that gives you 120. For example, 1 times 120, 2 times 60, 3 times 40, 4 times 30, and so on and so forth. For example, 5 times 24, 6 times 20, there's no 7, you can have 8 times 15 or 10 times 12. And those are all possibilities. And then you choose the one that you see that the numbers add up to 23. In this case, it's 8 and 15. Obviously, this is the long way. Quite often you will be able to find those numbers just by inspection of the numbers that you have. That depends how well you know your numbers. So negative 15 and negative 8 would work. Now when we already have those 2 numbers, we are going to split the middle term into negative 15 p square q square and negative 8 p square q square. And then copy the outside terms. Now we have expression with 4 terms. We can group them 2 by 2. So use the grouping strategy and take the common factor from the first group, which is 5p square. What's left is 4p square minus 3q square. And from the second term, which is negative 2q square. And what's left? 4p square minus 3q square. And finally, as you can see, this is the common bracket. That was our goal, to have such common bracket. You can write this common bracket as one factor and the remaining thing, which is 5p square minus 2q square, as the other factor. So decomposition is a little bit longer. However, you can always obtain your final answer. I would suggest that you try first to match the numbers, because it's usually faster. But if you work on the question for a minute or so, then you start the decomposition method. Again, this listing is not necessary. This is just if you can't find your numbers by inspection. The following strategy is to use special factoring. That means to use various formulas that we know and that help in factoring. The first formula, very common formula, it's a difference of squares. Here we have a squared minus b squared. It can be factored into two brackets that are actually called conjugates. The conjugate brackets, they will have exactly the same terms but opposite signs. And here we have a nice geometric explanation of this formula. If you have a square with this big side being a and inside a smaller square with the side b, then this piece, this part, is actually a minus b. So the area of a squared minus b squared is the total of the area of the green rectangle and a brown rectangle, because it's the big square minus the small square. Now this area can be rearranged, and if you position the brown rectangle on the side of the green rectangle, then notice that this distance is your a minus b, so it will exactly match the side of the green rectangle, which was a minus b, and therefore the area, which is a composition of green and brown, is actually a plus b, this is your a plus b, times a minus b. So that's a geometrical interpretation of the difference of squares formula. Now to use it, it's really easy. As soon as you detect that you have two terms in your expression and both terms are perfect squares of something, you just draw the two brackets and you list your terms under the square. So 25a squared is actually 5a bracket square. So 5a would be your first term. 64b squared is actually 8b under the square, right? 8b squared. So we'll list those terms and then use 1 plus 1 minus, and the thing is actually factored. Second question, again, remember about the first strategy, always check for common factors. Here we have a common factor, which will be 5 and y. What's left in the bracket is 4x to the 4 minus 25y squared. Now we can notice both of these terms are perfect squares. So the first term is a square of 2x squared, and the second term is a square of 5y. So that's your first bracket. Second bracket is composed of the same terms, just with minus. Again, the order of choosing the plus and minus doesn't really matter. Copy the 5y, and that's your final answer. The following example, again, it's a difference of squares. We have a square of something bigger, two terms, and a square of 10. So again, prepare two brackets. Your last term will be 10 for sure. 1 plus and 1 minus, and the first term is composed of the whole bracket, which is x plus y. X plus y. So as you see, you end up with the product of trinomials that wouldn't be easy to come up with if someone will actually want to square it first and then factor. So this is a desired form to see it as a difference of squares because we can follow the formula. Now the following example, again we can see it as difference of squares. So prepare two brackets. I make it a little bit longer because it's more terms. The first expression is a square of 7y. Write down 7y. Then it's plus or minus. And after that you have the whole bracket x minus 3. As long as you have plus in front of it, then we don't really need to write a bracket. However, if it's a minus, it's very important that you put your expression in a bracket. Because after dropping the bracket, you will have to switch the sign, otherwise you may forget about it. So the final answer is, copy the first bracket, 7y plus x minus 3, and the second bracket is 7y minus x, but plus 3. We just talked about difference of squares and how easy was it to factor. Now, the sum of squares is never factorable. For example, if I have x squared plus 9, this is not factorable, it is prime. And generally, any a squared plus b squared is a prime expression, can't be factored any farther. The following important formula is a perfect square of a sum or perfect square of a difference. It ends up with 3 terms, so you're squaring the first term, you're squaring the last term, which usually people remember to do, but quite often we forget about the middle term. It has to be there. It's 2 times a product of your first term and the last term. And again, the geometrical interpretation of this formula could be as follows. If I draw a square with side A, the red square, its area is a square. Then extend the side A of the red square by adding a distance b here and there. Therefore, we obtain a new square with sides a plus b, both ways. Therefore, the whole area is a plus b squared. How do you obtain this area? Well, you obtain it by taking the red area, which is a square, taking the green area, which is b square, but also you end up with 2 unattended areas. This is really a times b, and again a times b, so it's 2ab. So this is your middle term, 2ab. Similarly, for the perfect square of a difference, you will end up with the same formula, except that the middle term will take the sign, except that the middle term will have a minus. So the middle term really takes the sign from inside the bracket. Okay, let's try to apply this formula. In order to apply it, we actually need to train our minds to recognize the pattern of perfect square. So as soon as you see trinomial and the outside terms are perfect squares, like in this case, you figure out perfect square of what do we deal with. This is 4a, and this is just b. Then you take your terms under the square, that means 4a and b, multiply them, and double it, because of the formula double ab. So double 4a times b in this case. If the middle term agree with what you see in your expression, and in this case, yes, it does, it's 8ab, then you factor it out as a perfect square and you just copy your terms as you see them, 4a and the same sign as by the middle term plus b. So 4a plus b squared. Okay, let's try to apply the strategy here. I see trinomial. I see that this term is the same as 9n squared. The last term is 8m squared. And the middle term is actually 9n times 8m, which is 72, and double it is 144. So yes, it agrees. Therefore, I can fold it back to the perfect square of just 9n plus 8m. The first step in the following expression would be to take the greatest common factor out as usual. So I will take the minus for sure, and I would take 1x in front of the bracket. Then what's left is 9x squared y squared minus 30xy and plus 25 bracket. This equals, copy the negative x, and notice that this is again perfect square because the outside terms are perfect square of something, perfect square exactly of 3xy and 5. And the middle term is 5 times 3, 15, double it, it's 30xy. So yes, it is a perfect square formula. Open the bracket, square it, your terms that you discovered before, 3xy minus 5. Again, you're using the same sign as by the middle term. The following example consists of a bracket square minus 2 times a bracket plus 1. So treat this bracket as a new variable x minus y. Therefore, we can fold it back to the perfect square of your bracket, which is x minus y minus 1. So that was actually simple. The next two examples have 4 terms. So how can we deal with this? Well, if you have 4 terms, you would like to either group 2 by 2, but in this case, grouping 2 by 2 won't help because in the first 2 terms you have only x's, in the second 2 terms you have only y's. So it's impossible to obtain the same bracket, which means we need to try to group it differently. And for example, if we group the first 3 terms, we can notice that they constitute a perfect square. So let's fold this to the perfect square of something. It is perfect square of x plus 8, because double the 8 is 16 and 8 squared is 64. Now instead of writing minus 16y squared, let's write it as a square of something. This something is 4y. And now you can observe that we deal with a difference of squares. So let's prepare 2 brackets. And using difference of squares formula, copy the first term, x plus 8, under the square, and then copy the last term under the square. In between, you use 1 plus and 1 minus. Last example, again we have 4 terms. We see that the first 2 terms involve only a's and the last 2 terms involve b's. So there's no way to factor it by grouping 2 by 2. We need to factor it by grouping in different way. This time we would need to group the 25 and the rest of it. It's a little bit harder to see because in order to see that the last 3 terms constitute perfect square, we actually need to take the minus out. So let's rewrite it that way. Minus a squared minus 6ab plus b squared. Now you can see that this bracket can be folded back to a perfect square. So we can write 5 squared minus a perfect square of a minus 3b. This is a difference of squares that can be factored into 2 brackets. So we have 5 and 5 for sure. We have a minus 3b, a minus 3b, and we would need to put a plus here and a minus there. With plus there's no problem. With minus we have to remember that we are going to subtract the whole thing, so we need to have a bracket here. And finally rewrite it without the bracket. So 5 plus a minus 3b, and then 5 minus a plus 3b. That would be the final answer. The last formula that we need to deal with is the sum of cubes or difference of cubes. Sum of cubes factors into the short bracket and a long bracket. In the short bracket you have your terms under cubes as they were originally, and you use the same sign. You see, in both cases you use the same sign. In the long bracket you take the first term from your short bracket, square it, change the sign. See, there is a change. If it was plus in the short bracket, it is minus in the long bracket, and it was minus, then now it's plus. The second term is just a product, so it's not double a product like in your perfect square formula, but just a product, and the last term is b squared. So we need to memorize this formula. Let's see how it will work. First of all, realize that 8 is the same as 2 cubed, so you have sum of 2 cubes. Therefore, open a short bracket and a long bracket. In a short bracket, you list your terms x and 2 with the same sign. In the long bracket, you already look at what you have in the short. You square the first term, you change the sign, you make a product, and you square the last term. So that's all. In the following example, first of all, realize that 64a cubed is the same as 4a cubed. That 27b cubed is the same as 3b cubed. So, seeing it that way, you can use your short bracket and a long bracket. In a short bracket you have 4a minus 3b, the same sign. In the long bracket you square the first term, which is 16a squared. You change the sign, you make a product of your terms, 12ab, and you square the last term, which is 9b squared. And that will be all. So now when we reviewed how to factor difference of cubes, we can come back to this example and factor it a little bit farther. So we can copy x minus 3, and instead of x cubed minus 1, you have x minus 1, and the second bracket x squared, change the sign, product which is just x plus 1. Since your difference of cubes was squared, then we have to square these two brackets, and that will be the final complete factored form. Remember that the second bracket of a cubic formula, it's prime. It's not factorable anymore. So that's all what we can do here. And two more examples of applying cubic formula. In this case, first of all, take minus out of the bracket, and then you have a regular sum of cubes. This is actually a cube of y squared. So it's always good to realize what is it that we are cubing. So this term that we're cubing, we're taking in the first bracket. In the second bracket, you already refer to the first bracket and you say first square, change the sign, product of your terms, and the last term square, which is y squared squared, which is y to the 4. In this example, the first term is a little bit bigger, but still follow the same rule. The short bracket contains the first term, which is x plus 1, plus the expression that is cubed. So we have 5 that is cubed, so we're taking 5. That's the first bracket. Remember, first term, last term. In the big bracket, you take the first term and you square it. Minus, change the sign, product of your terms of 5 times x plus 1, and plus the last term square, so it's 25. Now what's left to do is to clean up a little bit. So in the first bracket, we can actually add 1 and 5, so it's x plus 6. And the last bracket, we need to square it. We need to perform perfect square. So it's x squared plus 2x plus 1 minus 5x minus 5 and plus 25. Finally, collect like terms, so we end up with x plus 6, x squared minus 3x. 25 minus 5 is 20 plus 1 is 21. And that will be the end of this factorization. We have a couple more examples to practice on. This time the instruction is factor completely. That means factor everything that we can using any strategy that we talk about. So first example, we deal with 4 terms. Let's try to group them 2 by 2. From the first two, take y to the 4 out, and you have y plus 1. From the last two, take minus out, and you have y plus 1. Now you see common factor, which is y plus 1. Take it out. What's in is y to the 4 minus 1, which can be considered as difference of squares, so you can factor it further into y plus 1. And y squared plus 1 and y squared minus 1. And finally, this is again difference of squares, so you end up with y plus 1, y squared plus 1, that's the copy part. And here is another y plus 1 and another y minus 1. So altogether, you can even write this as y plus 1 squared because of these two brackets. Then factor y squared plus 1, which is sum of squares, so it's not factorable any further. And finally, y minus 1. So you have 4 factors. The next example, again, we have 4 terms and we see some common factor. Let's take the common factor out. The common factor is 5. Then I have x cubed minus x squared y minus xy squared plus y cubed. Again, I can try to group them 2 by 2 like this. So copy the 5. Here I need to open a square bracket because whatever comes next is not in a factored form yet. This is just a preparation, factoring by grouping. So from the first 2 terms, I can take common factor x squared. What's left is x minus y. From the last 2 terms, we can take y squared. And what's left is again x minus y minus because I took one minus out. Complete the square bracket. Now let's take this bracket as a common factor, so you can write 5 and x minus y. And finally we have x squared minus y squared, which is a difference of squares, so it can be factored again. So final answer 5 times x minus y and x minus y and x plus y, because of difference of squares, this part. You can see that this can be recorded even shorter as 5x minus y squared and x plus y. The following example, this time I see 6 terms, but when I look at the first 3 terms, it seems like it's a perfect square. That's a perfect square of 2a minus 1. If I take minus from the last 3 terms, then I have negative b squared minus 6b plus 9, which is also a perfect square. So altogether I have 2a minus 1 squared minus, and instead of this trinomial, b minus 3 squared. So now you can see this as difference of two big squares. So following the difference of squares formula, prepare two brackets and copy the first term plus or minus the second term. Second term is b minus 3, so if it's plus, I don't need to worry. If it's minus, I need to put a bracket and then b minus 3. So finally, let's just open the red bracket, and your final answer would be 2a plus b. We can collect negative 3 and negative 1 as negative 4. And over here is 2a minus b, which is in front, and then it's minus 1 and plus 3, so it's plus 2. That will be your final simplified product. The following examples, well, we can notice we have trinomial with the variable, which is a whole bracket, a plus b and a plus b squared. So think about it globally as a plus b being a new variable. So to attack this problem, we basically need to think about the coefficients 4, 19, and 5. And we can think about guessing method because 5 is prime. So I know that in one bracket I will have to have 5 in the other one. And I need to think about splitting 4 into something times something. However, my middle term is quite large, it's 19. So middle term, as you remember, comes from multiplying inside and outside. To get 19, I probably need to multiply 5 by quite large number. 5 times 2 wouldn't work, it would be too small. So I would keep 4 here. That will give me 20 of something, of a bracket. And to get 19, I need to make a difference with 1. However, my overall sum must be more of negative. So I put negative 5 times 4, which is negative 20, and positive 1 times 1 here. And the product of last terms is plus 1. So altogether, it will give me the desired negative 19. What's left to do is just plug it in the variable, which is your whole bracket, a plus b, and simplify these two brackets by collecting like terms. So I'm going to erase the extra work, and after simplifying you end up with a plus b minus 5 and 4a plus 4b plus 1. The last example, again we have 3 terms and we have a common factor. Let's take this common factor, which is 8, outside of a big square bracket. So what's inside? Well, the first term x minus 3 squared minus 8 times x minus 3 and plus 16. Now we can notice that something square minus 8 times something plus 16, this is actually a perfect square, so we can fold it back to the perfect square of the bracket and minus 4. Therefore, after simplifying, this is the same as 8. Now I have x minus 3 minus 4, so it's x minus 7 and square it. Wow, so it's a very nice short expression after all. And that will be the end of our lesson for factoring.